Hi and welcome to this module on file permissions and ownership. In this module we will see how file permissions work in Linux with respect to who is allowed to do what with regards to files. The commands we will use in this module are change mode, umask, change owner, change group, and we will discuss the set UID bit, the set group ID bit and the sticky bit. But before we do that, let's go to Henry. Some vital properties of a user in Linux next to its name are its user ID and group ID. A user does have more properties, but we save those for later. And when the user logs in, a shell will be started on his behalf, and the user ID and the group ID of that user are connected to the shell. Now, if a user creates a file on disk, the user will be the owner of that file. This is realized by storing the user ID and the group ID of that user in the file properties. Next to that, the file will also get three sets of permissions. The first set is for the owner, the second set are the permissions for the group, and the third set is for the rest of the world, or others. So those are three sets of permissions. Now, how does that work? Now, permissions on files and directories in the bases are the following. First, you've got read. If you have the read permission, then you're allowed to read the contents of a file or the contents of a subdirectory. When you have the write permission, means you're allowed to change the contents of a file, or you're allowed to create files or copy files or rename files in subdirectories, which means you're allowed to write. And the execute bit is a little bit different for files and directories. If the execute bit on a file is set, that means that if the file is a program or a shell script, it will be executable, so you can run it. If the X is set on a subdirectory, that means that the user that has the X bit set will be able to access that directory. So if you don't have the execute bit on a directory, you're not allowed to make this directory into your working space. So you can't CD to it, so to say. Now, how do we set these permissions? There are two ways. First, there's the absolute mode, which uses the octal numeral system to set permissions. And then there's the symbolic mode, which seems to be somewhat more self-explanatory. But let's first look at this absolute mode. Now, this is not to insult your knowledge, but let's quickly look at some numeral systems. We are familiar with the decimal system, in which we have 10 characters to set a number before we need a second character or digit. So from 0 to 9, we can just use one digit. After that, we need a second digit to make it 10, 11, etc., up to 99, and then we need a third digit. The octal system has 8 single digits before we need a second one. So we go from 0 to 7 and then make it 8 by adding another digit. So 1 0 is 8, 1 1 is 9, 1 2 is 10, etc. Now, since we work with computers that use the binary system, we need 3 bits to go from 0 to 7. And this goes like this. So first we have 3 zeros, which is 0. Then we have a 001, which makes it 1. 010 is 2, 011 is 3, 100 is 4, etc. until we have all bits up, which makes it 7. Now, if we agree that 001 is the execute bit, 010 is the write bit, and 100 is the read bit, which means 1, 2, and 4, if you would up all bits, then you would have 7. So that would mean read, write, and execute. And if we want to deny all permissions, we simply can say 0. And as we saw, there are 3 sets of permissions. So we have the user ID, the group ID, and others. So for example, if we want to give the user all permissions, so read, write, and execute, and the group only read and execute, and the others also only read and execute, we should say 755, which means read, write, execute, read, execute, read, execute. Now let's have a look at some examples of using this absolute method. First, we create a file called file1 with the touch command. When we list the properties, we see we've got read, write, nothing, read, write, nothing, read, nothing, nothing. Lin user is the owner and lin user is also the group. So we change the permissions to 755. Now we see the execute bit has been added to the permissions. And we run the chmod 000, and that will remove all permissions. Next thing we do is we create a subdirectory, and let's call the subdirectory practice. And we look at the permissions by using the -ld parameter, which will not go into the directory but show us the properties of the directory. And we see we have the read, write, execute, and the X bit is set. So we set it to 700, and this directory will now only have permissions for the owner, which is linuser. Now, the more user-friendly way of setting permissions is using the symbolic mode, in which we know 3 players. You decide for whom you want to set the permissions, then whether you want to add or remove or make absolute. I will explain this equal sign in a second, and finally decide which permissions it concerns: read, write, execute, or any combination. So let's create file 1 once more and look at the permissions. We see we've got read, write, and read. Now we want to add an execute bit to all users. When we use a +X, it gives us the execute bit for everybody. Now we change it and we want to remove the execute bit from the rest of the world only. And we check that and we see that we have no execute bit for the rest of the world anymore. And we didn't touch the rest. Now we're going to change all permissions by setting the re-permission for all. So that means whatever the permissions were are gone. The only thing that everybody has now is the re-permission, which is an absolute setting, like change mode 444. Now I hope you're still with me. In the second part of this module, we'll have a look at umask, chown, chgroup, setuidbit, setgroupidbit, and stickybit. But if you like, you can pause this video and try the following commands in a terminal.